Okay guys, so today we are going to cover redox reactions. So in case you forgot from last course, redox stands for reduction oxidation. So this is a reaction in where the oxidation states of atoms are changed. So luckily for you, we're not going to have to calculate a whole lot of oxidation states in this class. We're just going to use this organic chemistry shortcut. So for this class, an organic molecule has been oxidized if it gains oxygens or loses hydrogens. Conversely, an organic molecule has been reduced if it loses oxygens or gains hydrogens. Okay, so our first reaction we're going to talk about is a reduction reaction, and this is catalytic hydrogenation. And this is a very important reaction for this class. We're going to see it all throughout the biochemistry sections. So this is a synthesis reaction where H2 adds across a multiple bond. So that means it can be an alkene or an alkyne. And it doesn't just have to be carbon-carbon multiple bonds. This also works on aldehydes and ketones. So this uses a metal catalyst, specifically one of these 7 metals that you see in green here. So all of the reactions for this class are pretty much going to use nickel, palladium, or platinum. But these other 4 in the lighter shade of green here, those can be used as well. So this reaction is hard to stop once it starts. So what I mean by that is, if you have a triple bond and you have an excess of hydrogen gas, you're going to reduce it from a triple bond to a double bond and keep reducing it all the way down to a single bond. Okay, so let's give it a try. So go ahead and pause this video and see if you can name the reactants in both of these reactions and draw and name the final products for both of these reactions. Okay, let's see what you got. So starting with the top reaction, we have a 2-carbon alkene, so that is ethene. And so we're going to break the double bond. And we're going to add a hydrogen to each previously double bonded carbon. And so our product, a 2-carbon alkane, would be ethane. Okay, so what about the bottom reaction? So a 2-carbon alkyne would be ethyne. So we're going to start by breaking our triple bond. And we're going to add a hydrogen to each double bonded carbon. But this reaction can keep going, because we have 2 moles of hydrogen gas here. So we can go ahead and break our double bond and add another hydrogen to each carbon. So here's our final product for this reaction, and its IUPAC name is also ethane. Okay, so like I said earlier, this reaction works on carbon-oxygen double bonds, just like it works on carbon-carbon double bonds. So go ahead and pause this video and see if you can finish out both of these reactions. So give me IUPAC names for both of our reactants and draw and give names for both of the products. Okay, let's see what you came up with. We'll start with the reaction on the left. So our reactant for the left reaction is a 4-carbon aldehyde. So that is butanal. And we're just going to break that double bond and add an H to both of the previously double bonded atoms. And let's go ahead and clean up our structure a little bit here, get rid of the implied hydrogens. So the IUPAC name for our final product here is 1-butanol. Okay, let's try this reaction on the right. So we have a ketone, and our parent chain has 6 carbons in a ring. So this reactant is cyclohexanone. And just like before, we're going to break the double bond, and we're going to add an H to each previously double bonded atom. Okay, let's clean up our structure again, draw a skeletal structure, and remove our implicit hydrogens. So the IUPAC name for our final product is cyclohexanol.